Alright guys, welcome back. We have another question from the second chapter of the Mechanics of Materials by Johnston. And in this one we have this block that we can see on the right hand side, and it's made of a magnesium alloy for which the elastic modulus is 45 gigapascal. We have the Poisson's ratio of 0.35, and we know that the sigma x is negative 180 megapascal, and the negative sign that we have in here is because the stress is going the opposite way of x-axis, and we need to determine the magnitude of the sigma y, which is also downward. So we are expecting something negative for sigma y2 in a condition that the height of the block will be 0, like the change in the height will be 0. B part, we need to find the corresponding change in area of the face ABCD, and the C part, corresponding change in volume of the block. So from the givens that we have, since the question is telling us there is no change in the height, so the delta y, or the change in y direction, has to be 0. And if that's 0, the epsilon is also 0, because it will be the delta y over the length, so there is no epsilon y. And also the question is telling us that like if you look at the figure, we see that there is no stress in z direction, so since it's missing, that means sigma z is also 0. All right, so we're going to be using the formula that we discussed in the previous video, and here we know that epsilon y would be equal to 1 over e sigma y minus Poisson's ratio sigma x minus Poisson's ratio times sigma z. So the y that we have in here, it has to be alone without any Poisson's ratio in the back. So we know that sigma z is equal to 0, so that's 0, and this will be equal to 0 because this is also 0. So we're gonna end up with sigma y minus Poisson's ratio sigma x is equal to 0. So sigma y would be Poisson's ratio times sigma x. So we have everything in here. We have minus 0.35 for Poisson's ratio, and sigma x is negative 180. So I put the negative sign in the back of the Poisson's ratio. So let's see what we get. So yeah, negative 63 megapascal, or negative 63 times 10 to the 6 Pascal. Again, we have a negative sign in here, which is correct because the sigma y is also in the opposite direction of y. So that was the answer for the A part. For the B part, we need to find the corresponding change in the area. So the initial area that we have is basically the, and we are talking about this area, we can call this side Lx and the other side Lz. So that's the initial length, basically Lx times Lz. And after the change in the length, we're gonna have Lx plus delta x times Lz plus delta z. And we know each of these are, like, we know epsilon is equal to delta over L. So basically each delta can be written as L times epsilon. So this will be basically Lx times epsilon x, Lz times epsilon, epsilon z. Now we can factor the L, so our A will turn into 1 plus epsilon x, Lz 1 plus epsilon. And since we are looking for the corresponding change, so we're going to have the difference of the area, which is A minus the initial area. And here we just have to multiply these. So let's start with the A. So Lx times LZ, and we're going to multiply these two. So 1 plus epsilon Z plus epsilon X. And since epsilon by itself is small value, when we multiply those two, it gets even more negligible. So we're just going to consider that one 0, and that was A, and we have to subtract this by A0, which was our initial length, area. So delta A would be basically Lx Lz. If we factor everything, we have 1 plus epsilon Z plus epsilon X minus 1, which is coming from this. And these two will be cancelled out. And delta A will be, so let's see what we have for Lx. So Lx is basically 100, Lz is 25, so 100 times 25, so each of them are millimeters, so 10 to the minus 3 for each of them. And we just need to figure out the value of the epsilon Z and epsilon X. And for doing that, we just have to use this formula again for each of them to find the epsilon X and epsilon Z. So 1 over E again, we know this is 0. Here we have this one 0. Everything's given now. We have sigma y from the previous part. Sigma x is also known. And we should be able to find each of these. I'm just going to put the final answer here just to save on some time. So epsilon x would be negative 3.51 times 10 to the negative 3. And epsilon z would be 1.89 times 10 to the minus 3. All right, so now we have to just put these two values in here. And if we do that, we're going to get negative 3.51, 10 to the minus 3 plus 1.89. And actually, we can factor one of these. So delta A can be calculated from this part. So 1.89 minus 3.51 times 100 times 25. And we can actually report it as millimeters squared instead of meters squared. So I'm just gonna remove this in here. Those are for the conversion, but now we can just report it as millimeters squared. And we're just gonna put the 10 to the negative 3 that we have in here times 10 to the negative 3. So that's gonna be 4.05 millimeters squared. And for the C part of the question, we need to find a change in the volume. And for the volume, basically we have same idea. V0 is Lx, Ly, Lz. And for the V, same idea. We're going to have Lx times 1 plus epsilon x. And if we can't L, just do the difference of these two. We have Lx, Ly, Lz. And now we have these three that we need to multiply. Again, whatever value that we have for more than epsilon, so epsilon x, epsilon y, we're going to consider 0. And if we have all three, it's going to get even smaller. So this will be also negative 2. So 1 times 1. So if we do that, we're just going to end up with Lx plus epsilon x, epsilon y, and epsilon z. The rest will be multiplication of these, which we consider 0. So that's pretty much everything that we need to do. So we have Lx, Ly, Lz, 100, 25, and Lz Let's see. Yeah, we have 40 for LZ, and we basically have each of these. Epsilon X was minus 3.51, epsilon Y was 0, and epsilon Z, again, same value, 1.89, 10 to the minus 3 for each. So 100 times 25 times 40 minus 3.451 plus 1.89 times 10 to the minus 3. And this is going to give us negative 162. We didn't do unit for millimeter, so it's going to be at the end millimeter cube. And yeah, that's going to be the final answer for this question. Hope everything was clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.